Example, h of omega equal to 1.5 and 0. This 1.5 values having some limitations. That limitations are 0 less than or equal to omega less than or equal to 20. Same as one more values are there. That value is 0. 0 having angular velocity greater than 20. So those two values can applicable on the graph. Okay, x-axis takes angular velocity or frequency omega, y-axis takes system h of omega. So now we may plot this 1.5 and 0 with the limit of 0 to 20 and 20 to omega. So we have three x-axis values 0, 20 and omega. In the problem mentioned 0 to 20 having 1.5 systems. Okay, so top of that 0 to 20 you put 1.5. Second values omega greater 20, that value is 0. So 1.5 and 0 values are mentioned on that graph. This is the given problem representative graph. Second thing is arch h of omega equal to minus 60 degree. Okay, if it is a mentioned negative value mean we face lot of frequency problem under the CT LTI level. So x-axis takes omega, y-axis takes arch h of omega. So this minus 60 degree mentioned below the x-axis value because that portion being negative. Okay. This responses of CT level and the LTI system, it mean sinusoidal input correlation of input is x of t is input, x of t always having some cosine angle of 2 cos del t plus 90 degree plus 5 cos of 25 t plus 120 degree. This input feed into the system h of omega, then we will get a related input of y of t. So y of t equal to 2h of 10 cos of 10t plus 90 degree plus arch h of 10 of plus 5h of 25 cos of 25t plus 120 degree plus arch h 25 equal to this summation will give 3 cos 10t plus 30 degree. This is basic frequency differentiation between input and output of weathering level. Okay, next we move on RC circuit. One circuit having one input x of t equal to v of t. Okay, that circuit consisting one resistor and one capacitor. Resistor values we may know the feeding input carrying the current. Okay, so resistor values having I of t. Then this I circulate through the resistor and capacitor. When the current reaches the capacitor, it will be IC of t. Okay, that time we get C equal to Y of t equal to BC of t. This is RC circuit. This RC circuit having some modification with the type of capacitor. The type of capacitor means complex impedance. Always capacitor having complex impedance. That complex impedance are 1 by j omega c. Okay. And this impedance related and compared with the input voltage xc of t equal to e power j omega t. So we know the two values xc of t equal to e power j omega t and capacitance values 1 by j omega c. Now we make to derive the output yc of t equal to 1 by j omega c by r plus 1 by j omega c e power j omega t. Now we take the denominator value into LCM. So after LCM, we will get 1 by RC is numerator and denominator is j omega plus 1 by RC into e power j omega t. Okay. Now we setting omega equal to omega naught. This omega naught value is replaced instead of xc of t equal to e power j omega naught t, and output to yc of t equal to 1 by RC j omega naught plus 1 by RC e power j omega naught t. Okay, those two values can have to multiply by the system h of omega equal to 1 by RC by j omega plus 1 by RC.